Good morning. Today we're going to talk about lesson 5, which is solving logarithmic equations. A couple things you need to be careful about is arguments of logs cannot be negative. What that means is you cannot have log of -7. You can't find that. So this would give me a no solution. That comes in handy when we're solving today, so just keep that in mind. Okay, so step 1 is you have to condense your logs. So you need to refer to page 9 in case you need that. So there's the different log rules. Step 2, it says use the one-to-one property. You have to have a log equal to a log. That means you can only have 2 logs total. If you don't have 2 logs, then that means you need to condense it further. But if you have log base b of m equal to log base b of n, then you can just say m is equal to n, so your logs would cancel out. And then your third and final step is that you need to solve and then check for extraneous solutions because that will happen. Here are those different log properties we talked about in order to condense. So maybe if you need to write those down, it doesn't hurt, is something to reference. All right, let's get started on this. Let's look at number 1. So on number 1, we have log base 5 of 5x plus 9. That's equal to log base 5 of 6x. So if you notice, on the left side I have a single log, on the right side I have a single log. That means I can cancel out these log base 5s, and I'm just left with 5x plus 9 is equal to 6x. So then from here you can go through and solve for x. I would subtract 5x over. I'm going to get 9 is equal to x. But not least, we said we need to check your solutions because you need to make sure that this part right here doesn't turn into a negative, or this one right here. So if I were to do this 5 times 9 plus 9, this is 45 plus 9, which is 54. 54 is not negative, so that first one works. Check it in on the other side. If you do 6 times 9, that equals 54. So 54 equals 54. We're good. Final answer on number 1 is 9. Okay, so skipping down, if you were to look at number 4. Number 4, you have log of y plus 5 plus log of 4 is equal to log 72. So I can't just go through and cross out these logs because I have more than 2 logs. That means on this left side I need to condense those. So since we have a plus, that means that we can rewrite this as multiplication. So now I have log of 4 times y plus 5 is equal to log of 72. Now I have a single log equal to a single log, so I can cancel those logs out. I'm left with 4 times y plus 5 is equal to 72. We now need to go through and solve, so I'm just going to go through and divide both sides by 4. Let me find my calculator. Whoop. Should have turned this on first. Okay. And you get y plus 5 equals 18. And then subtract 5, and you get y is equal to 13. Okay, let's try another one. Let's look at number 5. So on number 5, we have 3 times log base 7 of 4 is equal to log base 7 of 4a minus 8. Okay, so it looks like we have a single log equal to a single log, but if you notice you have this 3 over here, condensing means that I don't have any numbers out front either. So a quick reminder, this 3 becomes your exponent to your 4. And you get log base 7 of 4 cubed is equal to log base 7 of 4a minus 8. Now you can go through and you have a single log equal to a single log, so you can cancel out those log 7s. Actually figure out what 4 cubed is. In this case, we'd get 64. And continue solving. You can add 8 to both sides and you get 72 is equal to 4a. Divide both sides by 4 and you get a is equal to 18. When you double check this one really quick, 13 plus 5 is 18. And 18 times 4 gets you back to your 72, so you're good. Down here, if you would plug in your 18, I can't plug it in here because there's no variable. But if you do 4 times 18 minus 8, you get 64, which is the same thing as 4 cubed, so we're good. All right, let's try another one, and let's look at number 8. Okay, so for number 8, we have log base 3 of 2p minus 5 is equal to, I'm going to run out of room. Let's try it again. You got log base 3 of 2p minus 5 is equal to 2 times log 3 of 6 minus log 3 of 4. Now before I go through and combine these two logarithms, I need to do this 2 first. So I'm going to take this 2 and make it my exponent. So my left side will stay the same. On the right, this becomes log base 3 of 6 squared minus log base 3 of 4. Now I can go through and combine these two logarithms because I can't cancel them yet because I have too many. Left side, once again, stay the same. On the right side with subtraction, it turns into division. 6 squared, which is 36, goes on top. 4 goes on bottom. Now that I have a single log equal to a single log, I can cancel these out. I get 2p minus 5 is equal to 36 divided by 4, which is 9. Add 5 to both sides, and you get 2p equals 14. Divide by 2, so p equals 7. If you were to plug this back in, you have to check it here. 2 times 7 is 14, minus 5, which is 9. And we said 36 divided by 4 is also 9, so your answer works. All right, let's flip it over. We are now going to talk about, we have some quadratic equations, so let's look at number 9. You have log base 4 of m is equal to log base 4 of 18 minus 7m. So this one's actually pretty straightforward in the fact of you have a log equal to a log, so that means my logs are able to cancel. I'm going to get m squared is equal to 18 minus 7m. From here, though, whenever you have a square term, you always have to set it equal to 0. That means I'm going to subtract 18 and add my 7m. You're going to get m squared plus 7m minus 18 equal to 0. From here, factor it if you can, which you should. You're going to get m plus 9 and m minus 2, because 9 times negative 2 is negative 18, and 9 minus 2 is equal to 7, which is what you're trying to get. You're going to set these both equal to 0, and you're going to solve. You get m equals negative 9 and positive 2. Double these. When you plug in negative 9 and you square it, you get a positive 81. Negative 7 times negative 9 is negative 63. Positive 63 plus 18 equals 81, so we're good. Plugging your 2 squared is 4. Over here you get 14, and 18 minus 14 is 4. So both answers work out. Here's your final answer. Okay, so the last one that we're going to talk about today is type 2, which if you look right here, type 2 is that you're going to have log equal to a number. That means you're only going to have one log in the entire equation. That means you're going to have to convert between your two forms. So it means you're going to go from logarithmic form to exponential. So these are the ones that trip a lot of you up because it doesn't look like the ones we've talked about, and that's okay. It's not any more challenging, it's just more you have to remember how to rewrite it. Okay, let's try number 11. So look at number 11, you're going to get log base 2 of x minus 4 is equal to 6. So if you notice, you have the single log on the left and no log on the right. You cannot just cancel this one out because there's not one on this side. So going back to your exponent form, you're going to take your base 2 and it becomes your base to your 6. And then it will be equal to x minus 4. 2 to the 6 is 64. And then go through and solve. You'll add 4 to both sides, and you're going to get 68 is equal to x. Once again, you have to check your answer because you can't have a negative right here. 68 minus 4 is 64. And then if you do 2 to the 6, it equals each other out. Final answer, 68. Okay, let's look at number 12. So number 12, we have log base 3 of 4x plus 8 minus 7 equals negative 3. Now on this one, I don't have log equal to a number because I have this extra negative 7 here. You need to get rid of that first before you go through and rewrite it. It means I'm going to add 7 to both sides. I'm going to get log base 3 of 4x plus 8, and this is going to equal 4. So now that I have a single log equal to a number, you can take your 3 and it becomes your base to your 4. And then you get this equal to 4x plus 8. Keep solving. 3 to the 4th is 81. I'm going to subtract 8, and I'm going to get 73. And when you divide that, you get x is equal to 73 over 4. which is the same thing as 18.25. So once again, it's okay to get decimals or fractions. You just have to double check that they work. So when you go to plug that back in, you're going to get 73 plus 8, which is 81. And 81 is the same thing as 3 to the 4th. So we're good. Okay, so if you look down at the next couple, you're going to notice that there's multiple logarithms on these ones. Let's take a look at number 13. Okay, so for number 13, you're going to have log of 2x plus log of x minus 5, and this is going to equal 2. I don't have a single logarithm, I have two logarithms. So going back to your condensing, you're going to have to condense that into one logarithm. Since there's a plus sign, that means we can rewrite it as multiplication. Now that I have a single log equal to a number, I can rewrite it. This one doesn't have a base, but just a quick reminder, that base would be a 10 then. And you'll bring this over, so you're going to get 10 squared is equal to 2x squared minus 10x. So I don't know why I did that step, but you distribute that over to get this. Actually figure out what 10 squared is. In this case, it's 100. Okay, since we have a squared term, that means we need to set it equal to 0. I'm going to subtract 100 at both sides, and you're going to get 0 is equal to 2x squared minus 10x minus 100. We need to go through and factor, but your first step of factoring is always to take out your greatest common factor. In this case, my greatest common factor can be a 2. I get x squared minus 5x minus 50. We need to figure out numbers that multiply to 50 that can get back to 5. And we can have a 10 and 5, which means my 10 is negative, my 5 is positive. We need to set these equal to 0, and if I set 2 equal to 0, that's not a true statement. That one doesn't work. You get 0 is equal to x minus 10, and 0 is equal to x plus 5. When I go through and solve, you're going to get x is equal to 10, and x equals a negative 5. We need to go back and plug these in just to make sure that they work. If you plug in your 10 here, you get 2 times 10, which is 20, and you get 15 over here. And if you were to go, or excuse me, 5, and 20 times 5 is 100, so that one works. If I plug in negative 5, you're going to get log of negative 10x, or excuse me, negative 10. But you can't have log of a negative number, so that means negative 5 doesn't work. My only answer is 10. Okay, let's do one more like that just to make sure we get the concept, and then you're done. All right, let's do 15. So on number 15, we have log base 6 of x plus 9 plus log base 6 of x is equal to 2. So once again, I have two logarithms. I need to rewrite it as one logarithm. We have a plus again, which means we are multiplying, and you get x times x plus 9 is equal to 2. Now that I have a single logarithm equal to a number, I can take my base 6, making over here, and I get 6 squared is equal to x times x plus 9. On the left, actually figure out what 6 squared is, and that's 36. On the right, distribute to get x squared plus 9x. Since we have a square term, we have to set it equal to 0, so I'm going to subtract my 36, and I'll get x squared plus 9x minus 36. This should be able to factor to find numbers that multiply to 36 and add back to 9. You're actually going to use 12 and 3, which we haven't used in very long time. You need a positive 12 and negative 3. Set these both equal to 0 and we'll solve. And we'll get x equals a negative 12 and a positive 3. So when we go to plug this back in, you'll get negative 12 plus 9, which is negative 3. I cannot have log base 6 of a negative number, so the 12 automatically does not work. Let's plug in your 3. 3 plus 9 is 12. 3 multiply, you get 36, which equals 36 here. Final answer is 3. Now when you plug it in, log base of this and this will not equal 2. Basically what you're doing is you're plugging in your number here, and you would say log base 6 of 3 times 3 plus 9 is equal to 2. And then you get 36 because this is 12. And then you'll take your 6 squared equals 36, and that's how I checked my answer, that 36 equals 36. Alright guys, if you have any questions, please let me know. I'll let you know what your plan is for tomorrow.